Stores buy their merchandise at a cost. To make a profit, stores sell the merchandise at a price that is higher than the cost. The amount of increase from the cost to the selling price is called the markup. In this case, the selling price is 28, and the cost is 16. So the markup is $12. You can represent the amount of markup as a percent increase of the original cost. This percent is the percent markup. The amount of change is the markup, and the original quantity is the cost. You found that the markup is $12 and the cost is 16. Simplify the fraction to 3/4 or 75%. There is a 75% markup on the shirt.
This is an equation you can use to help you figure out percent markup. Percent markup equals the markup divided by the cost. But if you want to keep it simple and just keep it in the same format that we did with the other percent equations, you could just use the part equals percent times whole. You'll just have to know what each portion of the equation is. In percent markup, the part is the markup. Remember, you have to get the amount of change just like the other problems we did. So the markup is just the amount of change. So the difference between these two numbers. The percent is the percent markup, and the whole is the cost or the original cost of the shirt. So in this case, the original cost would be $16.
What is the percent markup for each item? Round to the nearest percent.
In order to figure out this problem, we can use our percent equation, which is part equals percent times whole. Now we have to remember what each portion of the equation is. So the part is considered the markup. So that's the amount of change. That means you have to subtract, in this case, the cost and the selling price. So when we go ahead and subtract $1.50 and we take away 25 cents, we are left with $1.25. So that is our part. That's how much it is marked up, $1.25. Now our percent is considered the percent markup, but we have to figure that out, so we'll just use a variable. Now the whole is the cost or the original amount, which is 25 cents. So I'm going to go ahead and write 25 hundredths. Now I need to isolate my variable by dividing 25 hundredths on both sides of the equal sign. And when I go ahead and divide that, I'm left with X on this side of the equal sign, and I'm left with 5 on this side of the equal sign. But remember, that's not your final answer. You have to change this number to a percentage. Decimal percent multiply, or you move it to the right 2 times. So you're going to add your zeros, and this is a 500% markup for the notebooks. 500% markup for the notebooks. Now we need to do the same thing for the bicycle. We're going to use our percent equation. Remember to figure out what each portion is. The part is the markup, and that is considered the amount of change. So we have to go ahead and subtract the 300 and the 180. And when we subtract that, we end up with 120. So 120 represents the markup. The percent is the percent markup, and that's unknown, so we'll use a variable. The whole is the cost or the original cost of the bicycle, which is 180. Now we need to go ahead and isolate our variable by dividing 180 on both sides of the equal sign. And I'm going to go ahead and simplify this. 120 and 18 are both divisible by 60. And when I go ahead and simplify that, I end up with 2/3. Now I'm going to change that to a decimal. That is 6/10 repeating. And when I change that to a percentage and I round it to the nearest percent, that will be about 67%. So the percent markup for the bicycles is about 67%. Now we're going to do the same thing for the car. We're going to use our percent equation. In this case, the part is considered the markup, and to get the markup is the amount of change. So we have to go ahead and subtract 12,000 and 8,000. And when we subtract 12,000 and 8,000, we get 4,000. So 4,000 represents the part, which is the markup. Our percent is the percent markup, and that is unknown. Our whole is the cost or the original cost of the car, which is 8,000. So now I'm going to go ahead and isolate my variable by dividing 8,000 on both sides of the equal sign. I'm left with x on this side. And if I simplify 4,000 and 8,000, that simplifies to 1/2. And we can convert that to a decimal. That'll be 5/10. And remember to change your decimal to a percent. Decimal percent multiply, or you move it to the right 2 times. So 5/10 written as a percentage is 50%. So that means the markup on the car is 50%. For the notebook, there was a $1.25 markup, which is considered 500% of the original cost. For the bicycle, there was a $120 markup, which is about 67% of the original cost. For the car, there was a $4,000 markup, which is 50% of the original cost for the car.
Airlines usually increase the price of their plane tickets as the day of the flight gets closer. What is the percent markup for the plane ticket below? When a store puts an item on sale, it reduces the selling price of the item. The amount of decrease from the selling price to the sale price is called the markdown. To find the markdown, subtract the sale price from the selling price. The selling price is 28 and the sale price is 21. So the markdown is $7. You can represent the amount of markdown as a percent decrease of the selling price. This percent is the percent markdown. The amount of change is the markdown and the original quantity is the selling price. So, percent markdown equals markdown divided by selling price. You found that the markdown is 7 and the selling price is 28. Simplify the fraction to 1/4 or 25%. So there is a 25% markdown on the shirt.
This problem, we can also use the regular percent equation we've been using, which is part equals percent times whole. And the part will be the markdown. The percent will be the percent markdown, and the whole will be the selling price. So you can use part equals percent times whole to figure this out as well.
5 years ago, a furniture store bought sofas for $835 each. What is the greatest whole percent that the manager can decrease the price of the sofa without losing money?
Here is our given information, or the information we know. We know the original cost is $835. The selling price was $1,599. What we need to know is the greatest percent markdown without losing money. Our plan is to find the greatest markdown possible, then find the greatest percent markdown possible. Step 1 is to find the greatest markdown possible without losing money. The sale price for the sofa cannot be lower than the cost that the store brought it for. So the greatest markdown is the number that brings the price down to the original cost. So the greatest markdown is equal to the selling price minus the cost. When we subtract that, we end up with 764. A markdown for more than 764 will lose the store money on the sale of the sofa. So we cannot mark it down more than $764. Step 2 is to find the greatest percent markdown possible. The greatest percent markdown is equal to the greatest markdown divided by the selling price. We can also use the part equals percent times whole. In this case, the part is the greatest markdown, which is $764. Our percent is unknown, and our whole is the selling price, which is $1,599. Then you just isolate your variable by dividing 1,599 on both sides of the equal sign, and then we'll get a decimal of 0 and 478 thousandths. And then you have to remember to change that to a percentage. Decimal percent multiply, or you move it to the right 2 times. So that's 47 8/10% here. And then it says the greatest whole percent markdown that the manager can discount the sofa is 47%, because 48% is greater than 478 thousandths. So in this case, even though 74 8/10% will round up to 48, if we round it up and give them a 48% markdown, we'll actually lose money, because the highest we can mark it down is $764. We cannot mark it down more than 47%, because if we mark it down to 48%, then the store will be losing money.
Each month at an electronics store, new televisions come in. The store manager puts older televisions on sale. What is the percent markdown on the television below?
This is good information to write down. Now, some of you may want to use the percent equation, part equals percent times whole. If you write it out that way, instead of writing it like this, you can write it as markup equals the percent markup times the cost. And you could do the same thing for the percent markdown. Markdown is equal to the percent markdown times the selling price, because that's your part, your percent, and your whole.
I call this position downward laying dog. It's tougher than it looks, believe me.
Relax Yoga Store buys yoga mats for $15 each. The store has a sale the following week. Does the store still make a profit on each mat during the sale? If so, how much of a profit?
Here is the information we know. We know the original cost of the mat is $15. The selling price is $38.99. The percent markdown is 20%. What we need to know is to find whether Relax Yoga Store profits from selling each yoga mat during the sale. Our plan is to find the sale price, then find the markup from the cost of the sale price. The first thing we need to do is figure out the markdown by using our markdown equation. And we can think of the part equals percent times whole formula. And we just have to know that the part is the markdown, the percent is the percent markdown, and the whole is the selling price. The markdown is unknown, so I'll use a variable P. Our percent markdown here says 20% off, so we have to make sure we use the decimal form of 20%. Percent to decimal, you divide, or you move the decimal point 2 times to the left. So 20% written as a decimal is 2/10. So we're going to use 2/10 as the percentage. Our whole, if you look here, it says our selling price. So our selling price is $38.99. Now we have to go ahead and multiply and get 20% of $38.99. When we multiply, this is what we end up with, but we have to remember this is money, so we can't have money in the thousands place. We have to round to the hundreds place. And when we go ahead and round to the hundreds place, we look here and then here. 5 or more, raise the score. 4 less, let it rest. So the 8 is 5 or more, so we're going to increase this 9 by 1. So you have to make sure you add, you carry the 1. So this will be $7.80. So that will be our markdown. We're marking it down $7.80. So that means we have to now move on to step 2 and figure out what the price is now. Step 2 is to find the sale price, and to find the sale price, we have to subtract the selling price and the markdown. So the selling price was $38.99. Then we have to go ahead and subtract the $7.80 from that. And when we go ahead and subtract that, it will let us know the sale price, which is $31.19. $31.19 lets us know the sale price. But now we have to go on to step 3. Step 3, find the markup from cost to the sale price. This will let us know the store's profit. So we have to do the markup equals the sale price minus the cost. So the sale price was $31.19, and then we had to subtract the original cost, which was $15. When we simplified, we ended up with $16.19. So yes, Relax Yoga Store will make a profit of $16.19 on each mat during the 20% off sale.
Relax Yoga Store negotiates to buy even more yoga mats from their seller if he can give them 35% off the original $15. If the seller gets the mats for $8.50, would he still make a profit on each mat with this deal? If so, how much of a profit?